My name is Matthew, and today I'll be presenting my capstone project, Species Composition and Stand Structure in the Urban Forest, comparing remnant forest patches and secondary growth in Toronto's ravine system. So since the mid-20th century, urbanization has been increasing rapidly around the world, but despite becoming more urbanized, human civilization continues to depend on forests. Forested areas within urban centers play a critical role in preserving urban biodiversity and provide essential ecosystem functions, such as air filtration, microclimate regulation, rainwater drainage, and sewage treatment, as well as providing recreational and cultural value. Unfortunately, the expansion of urban areas is often directly correlated with the destruction of nature. In addition, urban centers are often disproportionately vulnerable to the introduction and spread of non-native invasive species. This is a major threat to the health of urban forested areas, as native plants have been linked to increased plant abundance, biodiversity, and enhanced ecosystem services. So based on their origin, forested patches can be classified into two major categories: remnant forests and secondary forests. Remnant forests refer to areas that have remained naturally forested throughout urbanization, whereas secondary forests are those that have previously been cleared for alternative land uses. In urban areas, remnant forests often act as biodiversity hotspots. However, factors such as urban intensification and global climate change threaten their integrity and survival. The City of Toronto boasts an expansive network of green spaces and ravines. Covering roughly 17% of the city's area, Toronto's ravine network is one of the largest urban ecosystems in the world. Toronto's ravines provide valuable ecosystem services, which have been valued at over $60 million annually. However, over the last several decades, their ecological health has declined significantly, in part due to the increase of non-native plant abundance and the decrease of native plant biodiversity. So this summer, my classmate Nat and I carried out data collection in the G. Ross Lord Park, which, as you can see here, is located in North York and is part of the Don River West watershed. The park is used by the public for recreational activities such as dog walking, cycling, and organized sports. It is adjacent to major city roads and built-up commercial areas, including the North York campus of the pharmaceutical company Sanofi Pasteur, which can be seen here along the northeast side of the park. So historical mapping dating back to 1954 provides insight into the park's land use. It shows that much of the park was previously used for agricultural purposes and has been reforested within the last 71 years. Currently, the park is experiencing ecological degradation due to the encroachment of non-native plant species. This invasion threatens the survival and regeneration of native plant species, undermining the ecological integrity of the park. The University of Toronto has formed a partnership with Sanofi, which aims to expand their management activities in the park as part of their company-wide biodiversity initiative. The insight and recommendations provided from this project will be used to help inform these future management solutions. So to summarize, the primary objectives of this project are as follows: identify and evaluate the factors that influence the abundance and diversity of native plant species, examine how plant community composition differs across various forest types, and assess the effectiveness of diverse management approaches in sustaining essential ecosystem functions. So during the summer, vegetation sampling protocol, or VSP, was carried out in the G. Ross Lord Park. VSP is a quantitative, integrative, and adaptable method of fieldwork, which is used to sample vegetation types at a site-specific or landscape level. A total of 54 randomly selected fixed area plots were sampled for this project. Plots are circular with a radius of 11.28 meters and an area of 400 meters squared. As seen in the two figures here, plots are divided into quadrants using the cardinal directions, and the vegetation within the plots is stratified based on its height. So by overlaying historical mapping with VSP data in 2025, each of the plots was classified along 4 metrics based on their proximity to remnant forest patches. These 4 metrics were used as the independent or spatial variables for statistical analysis. So the map here shows the location of the 54 plots that were sampled this summer. The dark green areas here represent the portion of the park consisting of remnant forest patches, meaning that the remainder of the park is all of the secondary growth. And then these maps here represent the 4 independent variables. Remnant forest position indicates whether a plot's center is located within a remnant forest patch. And the binary metric divides this into two categories, inside and outside, whereas the categorical metric takes this a step further and divides the inside plots into forest edge and forest interior. It is worth noting that given the fragmented nature of the forest in these patches, there isn't any true forest interior in the park, but for the purposes of this project, I classified forest interior as being 15 meters or more from the inside of the remnant forest edges. And then the remaining two spatial variables were percent remnant forest cover and distance from the remnant forest edge. Now, on the other hand, the dependent variables were determined using the data collected during VSP. They include various measures of plant abundance and species richness. Additionally, the dependent variables include measures of floristic quality. So floristic quality is a method that's used to assess the ecological health of natural areas by examining its species composition. To measure floristic quality, a coefficient of conservatism, or a CC value, is assigned to each native plant. These values range from 1 to 10, with higher values being assigned to plant species with higher conservation value, and then a value of 0 being assigned to all non-native species. In addition, you can see here that the dependent variables have been divided further based on plant type or height-based strata. So while some of the variables include data from all of the plants in the plot, others include only data from tree species or only the plants present in the ground cover layer. So after defining all the variables, RStudio was used to run the following tests, aiming to assess whether any statistically significant differences exist between the plots based on their location relative to remnant forest patches. And so after running these tests, there are a handful of significant results that are worth highlighting. First, the dependent variable that was the most strongly influenced by differences between remnant forest patches and secondary growth was overall native species richness. This figure here shows that the native species richness was significantly higher in plots inside remnant forests compared to those outside the remnant forests. The map shows the same relationship. Green and red are used to indicate whether the plot is inside or outside the remnant forest, and the larger circles indicate higher rates of native species richness. And so here we have the results of some of the generalized linear models. The two on the left show that overall native species richness is positively and moderately correlated with both percent remnant forest cover and distance from remnant forest edge. This means that the closer proximity to remnant forest patches leads to higher native species richness, and the two figures on the right show that this trend is the same, even when only considering data from tree species or from plants in the ground cover layer. The next aspect of the results I want to highlight is the lack of measurable edge effects. So the categorical measure of remnant forest position that separated forest edge and forest interior provided very limited significant findings. This figure shows that while plots outside the remnant forest patches have lower native species richness, there's basically no difference between the forest edge and the forest interior plots. So next, I want to explore the impact of floristic quality. Overall, plots inside remnant forest patches had higher floristic quality and therefore stronger ecological health compared to those outside the remnant forest patches. These figures here show the relationship between average CC value and remnant forest position. And as you can see, average CC value was higher for the plots inside. And looking specifically at tree species, these figures show that both average CC value and maximum CC value of a plot is positively and moderately correlated with distance to remnant forest edge. This means that plots closer to remnant forest patches have more native tree species and more tree species of higher conservation value. This is a trend that's reflected throughout the results, as the tree-only data provided the largest portion of significant findings. These figures here show the average CC value of trees is higher for inside plots. And finally, tree species also provided the only significant relationship identified involving non-native species. These figures show that distance to remnant forest edge has a negative relationship with non-native tree abundance and non-native tree richness. This means the further away from remnant forest patches a plot is, the more non-native trees are likely to have taken over that plot. So some key points to discuss based on these results. First, remnant forest patches are shown to have higher rates of native species richness and higher levels of floristic quality. Surprisingly, the results showed no significant relationships between forest edge and forest interior. This result was unexpected, and further exploration with a larger sample size is worth exploring. However, just based on these findings, I would theorize that due to the small size and fragmented nature of the remnant forest patches in the G. Ross Lord Park, they are all experiencing some degree of edge effects throughout. And finally, it was tree species that demonstrated the strongest differences between remnant forest patches and secondary forests. This is in stark contrast to the lack of significant results identified when only considering plants in the ground cover layer. I think it's fair to assume that this contrast is largely due to tree species having longer lifespans and longer successional trajectories. So based on the results of this project, I have formulated 4 key recommendations, which can be used to inform future management activities in the G. Ross Lord Park. The first recommendation is to prioritize the protection of remnant forest patches. Remnant forest patches demonstrate higher rates of native plant diversity, greater floristic quality, and lower abundance and diversity of non-native tree species. These areas should be a priority for stewardship activities. Protection may include discouraging recreational activities and increasing monitoring of tree health in certain areas of the park, as well as carrying out invasive species management. And this brings us to the next recommendation, which is to implement targeted invasive species management at remnant forest edges. Remnant forest edges are often highly susceptible to invasion from non-native plant species, particularly if they're adjacent to roads, trails, or built-up areas. Invasive species management should prioritize removal activities at these edges to protect the ecological integrity of remnant forest patches. The third recommendation is to carry out assisted regeneration of native tree species in secondary forests. Secondary forests are shown to have lower native tree diversity and poorer floristic quality. Planting native canopy species and subcanopy species in these areas would accelerate succession and help create more resilient, healthier forest ecosystems. Recommended tree species are those with medium to high floristic quality that have already demonstrated an ability to establish themselves across the park. And the final recommendation is to implement and expand long-term monitoring. Vegetation sampling protocols should continue to be carried out on 5-year intervals to ensure information on ecosystem structure, composition, and health is current. There is also potential for future monitoring to expand to incorporate other metrics, such as measuring soil health indicators, performing water quality assessments, or monitoring small mammal or insect populations as indicators of ecosystem health. And so here are my references, and I just want to thank everyone that was involved in this project, my internal supervisor, Danijela, and the rest of her lab, our partners at Sanofi, including my external supervisor, Murray Fulmer, and all of my MSG classmates who were involved in this project. And with that, thank you all for listening.
Thank you, Matthew. Okay, so we have Murray Fulmer on the line. Murray, do you have a question?
I do have a couple of follow-ups. And the summary, it seemed to indicate that remnant forest might have different approaches for future monitoring and I guess remediation. Would you, I guess it's specific for Matt, so would you look at a different approach to remnant forest maintenance as opposed to non-remnant forest, or is it similar activities that you would suggest for both?
So I think there is a key difference. The key difference is basically the remnant forest patches have shown that they have a pretty healthy, diverse canopy of native species. So they basically have like very strong foundations. There's still lots of invasive plants there. And I think that invasive species removal activities should be prioritized there because I think that's where it could be the most effective. And then I guess the difference with the secondary forests is that they don't really have a strong canopy or any established native tree species there. So that's where I would say we should focus on establishing native tree species there if we're going to do any planting initiatives.
Okay. And I guess the other part would then be, do you know if there's any City of Toronto guidelines around that would be helpful for uh, future assessments and work in the park?
I don't know exactly, but I think with any of these activities, consultation with the City of Toronto is probably very important. I think in terms of like invasive species removal, I mean, we already met with them earlier this fall. I think like that could be carried out pretty easily, but if you are going to do regeneration of native tree species, I think that's probably a longer discussion before you start that.
Okay, fair enough. And thanks for all your work, Matt. Certainly it's appreciated and will contribute to our ongoing biodiversity activities in the Giros Lord Park.
Thank you.
Thank you, Murray. I'm wondering, Paul, if you would like to ask a question? Matthew, well done.
Thank you.
The presentation really doesn't do a lot of the questions, but it sounds like.
Oh, I can't really hear you.
It's on, you missed out the speak. No, thank you very much for your presentation. Which we speak, and my conclusion is that the outcome to move to the waste is improves on the edge, working towards.
Yeah, I think absolutely. Again, I think the remnant forest patches have shown that they're in a much healthier condition, and it is the edges where the non-native species are gonna encroach. I mean, we saw that with the non-native tree species in particular, like the closer you were to the remnant forest edges, the more that they were showing in abundance and richness. So those are the areas where I think we need to be fighting them off the most.
And to put the wheels on the four action plans, how would that be done? I mean, do we need a plan, or do we just go and do it intuitively? What would you describe?
I definitely think more planning would be required. I mean, that could be a project for future students. Me and Nat, when we were out there this summer, we weren't really looking specifically at the remnant forest patches or the edges there. And I think sending out the next students with a map of that, consciously looking at the remnant forest edges in particular and identifying areas for remediation efforts, that could go a long way.
Thank you. Thank you, Paul. We'll turn it over to Danijela.
That's a word, Matt, but I remember over the summer, not really, at the end of the summer, when they said like all the things should be bought. I was in the home and this is what, it's amazing, right? What a team of two students did. I'm curious about the secondary group. What species do you see there? Like, just in general, like what's coming up?
So I don't want to get too much into it because Nat's going to come up next and do a case by case of all of the major invasives. But I will say in terms of the tree species, like the main ones were Norway maple, Manitoba maple, and then buckthorn is just like throughout the whole park. Especially in the secondary forest, there's just huge portions of the park that are taken over by buckthorn. So I feel like that should probably be the main priority for remediation efforts.
What do you say that that's disturbed succession?
I don't know. I'm not sure exactly, like the amount of buckthorn that we saw throughout the whole park, it's basically killing off anything else that's there. Whether that's disturbed succession or not, I think there needs to be intervention.
Yeah, thank you.
More questions, Ben?
Good presentation, by the way. I have a follow-on questions about that. I know what's happening. I'm really curious about secondary growth and how that came to be. How the levels. Do you have any idea? Is that way to service development with the region versus an active effort to reforest there?
As far as I'm aware, there wasn't really any active efforts in the 1950s so that's my one point of reference. So in the 1950s, it was agricultural land. So it's basically grown in since then, based on how much Manitoba maple there is, especially like around the Don River and buckthorn. I find it hard to believe that there was active reforestation there, or at least not like a thorough process. It seems like it's just a handful of species that have come in and taken over everything.
Earlier in the presentation, you said the forest is 71 years old.
So, oh, sorry.
I'm trying to connect those two things. How old is the remnant forest? You maybe that 78 of the new forest?
Yeah, so the secondary forest, because my reference point is 1954, basically the secondary forests are all regenerated within the last 71 years. So that's why I said that. In terms of the remnant forest patches, we don't know the exact age. What we do know is that in 1954, it seemed to be mature forest and that everything around that was agricultural land. Obviously, you don't know 100% if an area has never been cleared, but the area that's the remnant forest is all like very like high slopes and around the Don River. I think it's very safe to assume it's never been cleared.
Thank you.
Max. Hey.
Great job. Really liked your hobby picture.
Thank you.
That was excellent. That's not all I have to say. Yeah, so I was wondering if you knew if there was any, I guess, ongoing work in the remnant forest areas for, I guess, invasive species management, like historically ever done, or at least in the park itself that's ever been done that might, I guess, explain a little bit of what you've seen that isn't just related to like event or yeah.
So what we do know is that Sanofi in the last few years has started doing some management efforts, but it's mostly limited to like waste pickup and species removal, or like invasive species removal. We did go in this summer and pull out some buckthorn and some garlic mustard, and I know they've done that in the last few years, but we don't really have comprehensive data on beyond that last few years if much has been done in those areas.
And then I guess my follow-up to that is, do you think in a couple of years after like a management plan has been built, sort of like based on this data, and then invasives were removed, like, do you think this would be a prime contender for like man-made assisted, I guess, regeneration of different wildlife, or do you think that it should be allowed to sort of like naturally regenerate to wherever it wants to for that? You remove the invasives.
I think it would have to be an ongoing process. Just being in there this summer, like there's so many non-native species, and I think a few years of management is not going to solve that problem. I think it would have to be ongoing, and especially like Sanofi clearly has the interest in doing this. They're adjacent to the ravine, so I don't see any reason why it couldn't continue forward.
Awesome, thank you.
Thanks, Max. More questions. Okay, so I didn't mention it earlier, but joining us also in the audience is Andy Simpson from Toronto Nature Stewards. He takes a great interest in these matters. So, give it to him.
Thanks, Matt. Andrew Simpson from Toronto Nature Stewards. We run a program that's supported of Sandy's lab that does community stewardship. And we actually did it in specialties, being fast. We actually will be working in the adjacent ravine next season to do exactly what you've identified as removing the invasive species. So thank you for highlighting the edge of that. That's something I've always wondered about, because I see it in my site in the Don Valley. It's incredible amount of invasive species. So just wondering if there's a way to modify that. The percentage of invasives is necessary.
There again. Yeah. So again, the next presentation coming up is going to get more into the invasives, case by case species. Yeah.
I'll hold my breath.
Okay.
More questions for Matt. I find it encouraging that the future of our urban forest seems to be in good hands with people like you and Max and others. Oh, here we go.
Excellent presentation. Well, I'm curious as to what species, based on what you observed in remnant forest, what species do you would recommend? You said native species that were there, but what did you see? Like, what sort of species are you suggesting to identify which species?
Yeah, so a few of the species, again, it would be species that had high CC values, like high floristic quality, and that we identified kind of throughout the area of the ravine, just because they proved they could establish there. Sorry. So I think like black maple, red oak, American beech were all ones that I think have CC values in the 6 to 8 range, which were kind of the highest we found in the park. And we did find those species throughout the park in certain areas. So I think those are examples of ones that I would recommend.
Thank you. Thanks, Matthew.